All right. Thank you, KringleCon. It is a pleasure to be up here. It's not the easiest flight getting up to the North Pole, but frankly, I had a lot of time to get some good connections in Delta Sky Club food, and I'm feeling pretty okay. But thank you, Santa. I see you in the wings. I did leave room for cookies. So without further ado, I want to make sure everyone has a fun time with this. It's going to be something that you don't usually think about at sort of CTF events and at hacker events where you're focused on the keyboard a lot. For those who don't know me, my name is Deviant, and I am a physical security specialist. I do covert entry work for companies and clients who want to get someone into a building and through securities like doors and locks. Now, what I'm going to present today is a talk about decoding keys. Now, why would that be useful? Well, I mean, if you're Santa over there, well, you don't need a key to get in a house, right? You can just zip your way down the chimney with a twinkle of your nose. But the rest of us want to get through a locked door to get inside of a building or get inside of a container. Well, you need a key. Now, many people think that if you don't have the key, lock picking is the only thing you can do. That's not true. Let's think about how locks actually work on the inside. If you haven't done any lock picking with me in the past or any of my friends, by all means, we'll teach you. But again, this is not a lock picking talk. This is a key decoding talk. Normally, inside of a lock, you have a series of pins. Those pins are called tumblers. And here we see there's red and blue pins, right? Well, the red pins are called the key pins. They interact with the blade of the key that you would use. And above those, we have those blue pins. Those are driver pins. When there's no key in the lock, like now, those driver pins are blocking and binding. They prevent the lock from turning. If you have the right key, well, that's how you get the pin stacks into alignment, letting everything line up. Now, if you don't have a key, yes, you could pick the lock, but wouldn't it be easier just to make a key of your own? That's what this talk is about. If you can get near the actual working key for a lock. I'm not talking about stealing the keys. That winds you up on the naughty list. I'm just talking about recording the detail of the key. Because every key has these cuts, right? They're called bitting cuts. Well, those bitting cuts have discrete values. It's not an infinite range of possible depths. What we have here are different potential manufacturer-specified cut positions. And every cut on any key is going to be in one of those discrete specific spots. Manufacturers have charts that exist. Locksmiths have access to resources that are charts and bidding resources like this. Well, if you understand that it's a limited set of data for those cuts to be in different positions, it's actually possible to decode a key very quickly and then go produce your own later on a key machine. And that's what we can do. If you can get your hands on a key, even briefly, let's say you just have the best case scenario. You have permission to use a key for a moment, but you're expected to return it. All right, you've got the key in your hands. You're going to go off to the supply room, get something out of there that somebody's requesting. Well, let's say you have calipers in your pocket. This is the cheapest caliper you can find on Amazon. Makes a great stocking stuffer for you or a friend. A simple set of calipers will allow you to very rapidly measure the thickness and size of the key blade at each of those bidding positions. And remember, if you know the brand of lock, in this case, I can look at this key and I can tell just by the head of this key, that's a Sargent brand lock. Well, I know the brand Sargent has a bidding chart. Here it is right here. It's all laid out in thousandths of an inch. Well, here's our bidding values, our cut depth values. Let's compare those to the values we might see with a caliper. If we have a key here, the first key in the jaw of the caliper is the first cut, is 0.3085. Does that look like any possible entry on our bidding chart up there? Sure does. That looks like a value of a 2, cut depth number 2 on the Sargent chart. All right, well, let's move on to the next position. In the second position, we have a thickness from our calipers of 0.2875. Well, I'm going to say that's darn close to 288 on the thousandth of an inch scale. So we know that's a 3 value. We're already chugging along. We're getting the manufacturer's bidding code off this key just by measuring it. Here's another 3 in the next position. How about this position, 3075? Well, again, it's another 2. Now, things aren't always going to be dead perfect, right? Here we have 0.2485. Well, that looks pretty good to me on, okay, 0.248, that looks great too. But even if it was off by 1/100 of an inch or so, it's still going to be valid in the lock. 2885, okay, another 3 again. And there you have it. There you have 233253. Those are cut depths that you could then take to a locksmith, or you could punch in to a code cutting key machine. You know, most people think of copying a key either at a locksmith or at Home Depot as having the original key, walking in with the original, asking somebody, say, okay, could I have one of those blanks? Okay, here you go, and then they churn it out. You don't need the original at a key machine in many instances. If someone has a key origination machine, a code cutting machine, which many locksmiths do, you can just have this code. So, you know, you returned the key you were loaned, you returned it 60 seconds or a minute later, all of a sudden you don't need the physical key later on. Now this is measuring with calipers. That's not the only thing you can use. Locksmiths very frequently in the field will decode keys using a specific card, a metal card called a key gauge. And if you can't figure out how this would work, it's not too hard to visualize. You slide a key blade right through the slot and move it laterally until it stops somewhere on this little stair-step pattern. In this case, we have a bidding cut on this Schlage key. That's a 2 value. The next one behind it, we can kind of see there in the shadows, it would be a much deeper value that would be further along down the key gauge slot. So this is a really rapid and precise way to operate, you know, key measurement tactics. What's the trade-off? Well, with a key gauge, you need to be interacting with a key that's actually specified on the gauge. It's a limited set of brands. With those calipers, though, you can absolutely do it to any brand whatsoever, no matter how obscure. In the end, though, if you can get those bidding values, those cut depth values, you can absolutely produce a key later without having the key right there in the store. But let's say you can't go hands-on with the key. Let's say you need an alternative technique, right? Let's say the key isn't really being handed to you, it's just in your vicinity. Maybe it's on someone's desk and they're kind of distracted and using a phone. Maybe the person doesn't even know that you're looking at the key because they're just out at a bar or a restaurant. They could just plonk their keys down and they're not really paying attention to you. You're just a stranger who sat down next to them. If you can take a photograph of a key, absolutely you can decode that key. Remember, every bidding possible depth value, every cut value on the key should be a standard interval, standard distance from one another, standard distance down from the top of an uncut blank. You can use an image editor and lay over top of the image you took. You can actually lay these lines, these guidelines over top and decode it just by visually looking at the depths relative to one another. Now, in a perfect world, you would have some graph paper behind the key, really nice lighting. A sharp, crisp photo like this is something you can import into an image editor like Photoshop or GIMP. It will make adjustment and scale much easier. For this purpose, I keep graph paper in my wallet. A little graph paper card you can slide under a key. I've taken photos literally in someone's office where they've turned around for all of 10 seconds. I said, hey, you know, I'm here to pick up the resources from last year's final reports. They told me you have the box somewhere in here, right? And somebody unlocks a thing, puts the keys down, rummages through a closet. And while they're just, you know, they got their back turned to me for 10 seconds, out comes the graph paper, snap goes my photo, and there you go. If you want to ever try this with or without graph paper, I've created overlay guidelines for most common brands of lock. I've uploaded all of these to my GitHub repository where I keep all my decoding resources. Everyone's free to use them. Let's take an actual real-world example. And nothing's so beautiful and crisp as a dead-on graph paper photograph. Let's take a look at this key. This was in a building where I was invited to give a talk. I'm getting my laptop hooked up, and they had to open up the network closet to turn on the projection equipment and so forth. And as they did, one of the staff there just kind of left the key on the desk for a minute, making sure my HDMI signal was working. Well, I took out my phone, snapped a little photo. Now this is not great at all, right? This is at a weird oblique angle. The lighting is not crisp. There's a shadow, but we can still import this image into an image editor and use, if you have any kind of Photoshop skill, you can straighten this out. You can get it a little squared off and true. And using my guidelines, we can decode this. The guidelines I've created have a series of black edges, which you line up with the edges of the blade of the key, the uncut part of the key. And then all of these intermediary lines represent even and odd cut depths. The blue lines are evens, the gray lines are odds. So knowing that, well, why would there be a blue line up here? Well, that's because the Schlage lock, the Schlage brand, starts with a 0. So knowing that, we've got a possible 0 up here, right? Well, it's certainly not a 0. Let's see what cut this first position is. 3, 4. Ah, that looks pretty lined up. It's a 5. All right, very good depth there. How about this next position? It's clearly a blue line. Looks like an even number. Well, it's not a 0. What is it? It's a 2. Over here, we've got a very deep cut. I'll let you know right now that Schlage goes all the way down to a depth of 9. That's this last gray line. Well, it's not a 9. What is it? What's the next odd number? It's a 7. And the one next to that, it's one value less. It's a 6. Here we have a 7 again. It looks like to me. What do you think of this last one? 0, 1, 2. There you go. That photo, that terrible, terrible photo that I just kind of whipped my phone out and barely grabbed, that's enough to decode and fully get all the bitting you need to make and produce a working key for this room. Now, if you take photos in the field like this, just one more tip from me to you, if you want to make your life just marginally easier, take a second to try to separate the key from any other keys that might be there. That will help you out. If you can give it a little bit of a black background, that's another thing. You know, just get some high contrast here. I'm just using a hat. There we are. The brim of my hat is black. This key is separated out. Nice stamp on this key. What does that tell us? Well, it's not just any key. It's probably the master key for this entire building. And we have grid lines. We have guidelines. In this case, it's the Sargent brand. And you could decode this one just the same. So yeah, all of my resources for visually decoding keys and numerically decoding them, if you're just using calipers, they're all up on my GitHub page. Anybody can do this. It is not difficult at all. And I really think that this might just be very useful if you ever wind up having a situation where you need to get into a building or out of a building. Who knows, maybe this will show up in future contests and events that you might be participating in. So I really appreciate being here. I enjoy the chance to be part of this. Can anyone think they can decode this before I go? Notice this is an odd one, right? This edge line, all of my guides will list the values. In the Sargent brand of lock, no cut at all is a 1 value. Ah, interesting, interesting. Do we have any 1s? Well, no, this isn't a cut out here. This is just the uncut edge of the blade. The first cut, I would call that a 3. Down here, we have another gray line. It's also odd. I'd call that, what do you think? I'd say it's a 5. Here we have a 3 again. Ah, quite the conundrum here. Was this a badly cut key? Is my photograph off? What would you do in the real world? Let's skip that position for a second. Let's see how we look out at the edge. This one, although a little bit sloppy, I would probably call that a blue line here. I'd call that a 6. And towards the tip, we have one more blue. We have one more even cut. That's a 4. So we had 3, 5, 3, question mark, 6, 4. If you were trying to produce a key in the real world, well, if you're not sure if this is a 4 or a 5, go with the lesser value. Go ahead and cut 3, 5, 3, 4, 6, 4. And if that doesn't work in the lock, go ahead and just hand file it down. Maybe even hand file it halfway between. If the lock is that worn out and this key is working, try to hit the mid value. If that doesn't work, try the 5. So in the real world, it's a pretty forgiving process. It's a very accurate process. You'll really be amazed at how much you can do, even with terrible cell phone kind of speedy on the fly covert photos. So whether you decode with a caliper or a picture, producing keys, even when you've only been near them for a second, is easier than you might think. I hope you enjoy this material. I hope you enjoy the talk, and I hope you enjoy the rest of KringleCon. Santa, elves, Mrs. Claus, and everyone else, it's really been a pleasure to be here. I hope you let me stick around a few days after the holidays when we can all actually put our feet up and relax and you're not working so hard. But everyone else, thank you very much. Have a very good time. Have very, very happy holidays.